Hello, this is Mr. Stansbury. I'm going to go through the notes with you on completing the square. At the end of this, you should be able to say I can find the solutions of a quadratic equation by completing the square. And then I can explain the steps needed to complete the square and why it's a valuable tool. Okay, so we are going to do two different problems here and we're going to solve them by completing the square. Okay, and you're probably like, what are you talking about? What's completing the square? Well, I'm going to take you through all the steps here. Okay, so first step is to isolate the constant. So that means, see how you got -3, that's a constant. We also have this 7 over here, which is also a constant. So that means we want to get all the constants on one side and everything else with x's or whatever the variable is on the other side. So we're going to want to subtract 7 from both sides, and we get 3x squared plus 12x equals -10. Okay. The next step we're going to want to do is we're going to want to factor the a. So this means whatever's out in front of the x squared, we got to factor that out of both of these on this side here. So we got to factor a 3 out of both of these, right? So that's going to be 3. If you take 3x squared, let's do this. Let's give ourselves a little bit of room to work. So we're going to divide this by 3 and divide this by 3, right? So 3x squared, factor the 3 out, we're just left with x squared. 12x divided by 3 is going to be 4x. And there is factoring our a out. So we factored whatever is in front of the x squared out. Okay? Next step is to find half of whatever the b term is. So in this case here, our b term is the 4. So we're going to take 4 divided by 2, and we get 2. And I'm actually going to circle it because we're going to use this 2 later on, so it's really good to make sure that you remember where it came from. Next thing we're going to do is we are going to square the result of step 3. So we're going to square this. So we take our 2 and we square it, and we get 4. Okay, now we're going to add that result to both sides. So now here's where it's a little bit weird. So we have this 3. Oops, that's supposed to be a 3. 3 times x squared plus 4x. And what we're going to do is we're going to take this 4 and add it in right here. Okay, so really, if you look at it, what did we actually add to this side? Because this whole thing needs to be multiplied by 3. So really, this is 3 times 4, which is 12. So we actually added 12 to this side. So what we're going to need to do is take the -10 that we have from way up here, and we're going to need to add 12 to that. Okay, so that's going to give it, and we'll just rewrite this. Well, really, this side over here is just going to end up equaling 2, right? So we have 3 times x squared plus 4x plus 4 equals 2. Okay? And then what we're going to do is we're going to write this now as a perfect square. Okay? Oops. So what that means, this here is a perfect square. So what we'll do is we're going to say that's 3 times, and then instead of writing x squared plus 4x plus 2, it's going to be x squared. And guess what? This here, this 2, that's why I said, hey, we're going to circle it because we're going to use it again later. That goes right here. Plus, that's a positive 2, so it's going to be 3 times x plus 2 squared. And then that's still going to equal 2 over here. And then our last step here is to solve this whole thing for x. So this is just like what we were doing in the last section. So that means we're going to want to divide both sides by 3. So we get x plus 2 squared equals, 2/3. Right? We got to get rid of the square, so we have to square root both sides. So we get x plus 2 equals, because this square and root cancel each other out, equals plus or minus square root of 2 over the square root of 3. And the reason why we're writing it like that is because, remember, we can't have a root in the denominator, so we have to rationalize the denominator. So we have to multiply both the top and bottom by the root 3. Right? So we get x plus 2 equals, let's see, on the top here, 2 times, since they're both inside the root, we just multiply them together. So that's plus or minus root 6. And then root 3 times root 3 is root 9, which we know is just 3. So we get plus or minus root 6 over 3. And then our last step is we've got to subtract 2 from both sides. And remember, this negative 2 is going to go up in front here. Don't subtract it from the plus or minus. It's up in front of that. So that means that this all goes to x equals, because these cancel, and we get plus or minus. Oh, actually, remember this negative 2 is going to go in front. So we do negative 2 plus or minus root 6 over 3. And that is our answer. Oops, I wrote through the answer. Okay, and that is our solution for this one. Okay, we're just going to go through and do another example here, and that will take us to the end. But before we do that, let's take a quick little comedy break. That's a determined dog. Love it. Okay. First thing, isolate the constant. So get this 8 over on the other side. So we're going to add 8 to both sides, and we get 2x squared plus 10x equals 8. Step 2, factor out whatever's in front of the x squared, right? So we got to divide both sides over here by 2, factoring the 2 out. So that's going to leave us with 2x squared. 10 divided by 2 is 5x. Equals 8. Now we're going to find half of this b term, so we take 5 and divide it by 2, and we get 5 halves. Not going to be great when we got to go through and square it for the next step, but that's okay. We'll do it anyway. So square the result of step 3. So 5 halves squared is going to give us 25 fourths. Okay? So what we got to do now is we got to add the 25 fourths to both sides, right? So we're going to go 2 times x squared plus 5 halves x plus 25 fourths over here, right? And really, remember, we're doing 25 fourths times 2 is what we're actually adding to the left side. So we got to take our 8 and we got to add 25 fourths times 2, which basically just simplifies that down to 25 halves, right? 25 halves. So 8 plus 25 halves. Okay. We are going to now write this here as a perfect square. So we got 2 times x. And remember, it's whatever this part is right here, whatever half of that b term is, so x, and that's positive, so plus 5 halves squared equals, right, it's a perfect square, and then equals, let's see, let's figure out what this actually is over here, right? 25 halves is what, 12 and a half? So 8 plus 12 and a half is 20 and a half, or 20.5, right? So we wrote this as a perfect square, and then now we're simply going to solve this thing for x. So first thing, divide by 2. That's probably, yeah, that's so pleasant, isn't it? So we got x plus 5, 5 halves, right, squared. So 20 and a half divided by 2 is 10.5 divided by 2, which is going to give us what, 5.25? That's a 5. 5.25, or 5 1/4, right? And then we've got to square root both sides. All right, so I should have left this in a different form. That's okay. 5.25. We're gonna. That means that's 5 1/4. So we're gonna 5 times 4 is 20 plus 1 is 21/4. We're going to rewrite it like that. It's just going to make it easier when we have to go through and rationalize the denominator, right? So we got x plus 5 halves equals, let's see, we are doing plus or minus the square root of 21/4. Okay, good news is, look, the reason why we did this is, look, square root of 4 is going to work out nice for us. So we got x plus 5 halves equals plus or minus the square root of 21/4. So then all we got to do is subtract 5 halves from both sides. And we should be done. X equals negative 5 halves plus or minus square root of 21/4. Okay? I know that's not pleasant, but that's really kind of how that works. There we go, plus or minus square root of 21/4. I'm fine if you leave it like that. We could simplify that further, but let's for now, let's just call that good. Okay? Okay, one last quick thing to point out is that back when we write these two equations here as a perfect square, what we can actually do is we can actually move the numbers over from the right side, set it equal to 0, and this is going to be in what we call vertex form. So if we subtract 2 from both sides here, we would get 3 times x plus 2 squared minus 2 equals 0, or we would just say y equals, and this is what we call vertex form. Okay, because if you look at this, you can actually see that the vertex is going to be at -2 and -2. That would be the vertex of this equation here. Same idea here. If we subtracted 20.5 here, 20.5 from both sides, we get 2 times x plus 5 halves squared minus 20.5 equals y. So the vertex here is going to be at -5 halves and -20.5. Okay? Okay, if you have any further questions on any of this, please feel free to ask in class. Thanks.